In this video, you will experience the effects of M-System's lightning surge protectors M-Rester for electronic equipment using a demonstration kit. On a hot summer day, a violent updraft occurs everywhere on the ground, and the electric charge generated by the friction of the air is discharged onto the ground. This is lightning. The computerization of industrial instruments has dramatically increased the transmission distance of measurement signals. But electronic equipment has a weakness in that it is easily destroyed by induced lightning surge voltage. Especially with the recent climate change, lightning damage is on the increase every year. In 1973, M-System developed Japan's first surge protector for DC measurement signals, the M-Rester. Since then, we have built up a track record of lightning protection using M-Rester not only for instrumentation equipment in process plants, but also for air conditioning and monitoring equipment in buildings, and various types of network equipment. This is the M-Rester demonstration kit. By applying a simulated lightning surge comparable to an induced lightning to a 4 to 20 milliampere signal line, the effectiveness of the surge protector can be tested. For example, when a sensor is installed in the field and signals are monitored in the control room, if a surge protector is not installed, lightning surges may enter the signal line and destroy the electronic equipment at both ends of the line when it is hit by lightning. If a surge protector is installed, the surge protector will absorb the lightning surge and protect these electronic devices. In the M-Rester demonstration kit, the sensor signal is converted to a 4 to 20 milliampere signal by a potentiometer transmitter and connected to the signal transmitter, which is the receiving instrument in the control room. When the input voltage potentiometer is turned, the output signal of the signal conditioner, 1 to 5 volts, is displayed on the output monitor meter. In order to test the effectiveness of the surge protector, a high-voltage generator circuit is incorporated to apply a high voltage that simulates a lightning surge to the 4 to 20 milliampere signal line. In the high-voltage generator circuit, the voltage generated by the voltage booster circuit is charged to an 8 microfarad oil capacitor to create a high voltage of 1000 volts DC. Note that the 4 to 20 milliampere signal line is wired with 20 ohm connected to the base of the surge protector, so the signal will not be interrupted even without the surge protector circuit. Also, when a surge protector is inserted, it will not affect the signal, so the meter needle will not move. On the front of the demo kit, there are charge, discharge, and start buttons. Pressing the charge button will charge the unit with 1000 volts DC, which simulates a lightning surge. Press the start button to apply the lightning surge. After the application test, press the discharge button to discharge the remaining charge in the capacitor and return it to 0 volts for safety. You can also apply a lightning surge to the negative signal line by switching the polarity with the polarity switch. Now, let's actually see how destructive 1000 volts DC is in a charged capacitor. Here, a resistor is used in place of the transmitter. Replace the transmitter on the field side with a dummy module. Open the front cover and connect the substitute resistor. This surge protector has a 20 ohm resistor in the base, and in order to disconnect the surge protector from the signal loop completely, we will replace it with a bypass module. Remove the surge protector's main module and the transmitter on the receiving instrument side. Now the receiving instrument side is completely open. Press the charge button to charge 1000 volts DC. This 1000 volts DC will be applied directly to the resistor of the dummy module. Please note that there will be a loud popping sound when the resistor is destroyed. Now press the start button. As you can see, the resistor has been destroyed with a loud noise. The induced voltage from an actual lightning surge can reach several thousand volts, so you can see that the destructive power is tremendous. Next, with the surge protector in place, we apply 1000 volts DC to the signal line. 1000 volts DC is now charged. Press the start button to apply the lightning surge. As you can see, there is no effect of the lightning surge because the M resistor is protecting the transmitter. Now, let's switch the polarity switch and apply a lightning surge to the negative signal line. 1000 volts DC is now charged. Press the start button to apply the lightning surge. As you saw in the beginning, there is no abnormality in the signal loop, and the signal from the field sensor is observed by the meter in the control room. We hope that this demonstration has illustrated the effectiveness of M resistor, the surge protector of M system, which specializes in the protection of electronic equipment. With 46 years of experience and 1.42 million units of reliable protection, the experience and track record of M resistor, lightning surge protectors for electronic equipment, is the key to success in this IT age. M System offers specialized surge protectors for each application, such as standard instrumentation signals, various open networks, Ethernet for protecting IoT devices, and power supplies. We hope you will consider the M resistor series. Thank you very much.